In 5.1, we defined a lot of the basic geometric terms, angles, lines, rays. Now we're going to use what we know about those terms and define a new theorem about triangles. Copy down your target, and I want you to think about this first part like a little warm-up. So try this, pause the video, try it with your target, answer this question, and then press play. So now that you've done your target and you've hopefully reflected on this, this is something interesting. If you take a triangle, and you could try this, you could cut a triangle out of a piece of paper, okay? And then rip off each corner. So if you rip the paper right along these lines, and then if you put all the vertices of your triangle together, so all the angles that you ripped off, squish them together. So turn this, flip it around, push this over, and push this over. You can see that these angles all together line up to form a line. And what do you know about the degrees of a line? Well, on one side of a line, right, there's how many degrees total? 180 degrees. This will work for every triangle. So the sum of the angles in a triangle will always form a line, which means they will always add up to 180 degrees. This is actually called the triangle sum theorem, and you will use this in geometry especially, but you're going to use it now. You may use it a little bit next year in algebra. So fill in the triangle sum theorem. The angle measures of any triangle in a plane always add to 180. We give you a numerical example, and you also can write an algebraic example here. So no matter what the measures are, you can always write an equation, and this is how we're going to show our work. Just like this with the equation, adding up the angles to equal 180, and then we can solve for one of the values if we want. So let's try this now. Let's apply this in example 1. Find the measure of each missing angle. Well, you have to use the triangle sum theorem. We know for each one of these triangles, the angles add up to 180 degrees. So you just need to fill in what you're adding up. Well, angle C plus angle 42, that has 42 degrees, plus, what is this one here? That angle, we know its measure. This symbol means that it is a right angle, which means 90 degrees. I want you to start every problem with an equation and show your work. Here's your equation. C plus 42 plus 90 equals 180. Now let's solve this. Combine your like terms first. So we would have C plus, what's 42 plus 90? And that's going to equal 180 degrees. Now to solve for C, get C by itself, what would you do? And do the subtraction. So C is going to equal 180 minus 32, 48 degrees. It is an angle measure, so we want to have the angle measures to be 48 degrees. You can say C is the value of 48, or you can say the angle's measure is 48 degrees now. Try the next one then. What would be your equation for the second triangle? Again, every triangle, the angles add up to 180 degrees. So you're just writing your equation. In this one we have 73 plus 44 plus P. The order over here doesn't matter. We have the commutative property that allows us to know that. You can add the numbers in any order. Now go ahead and combine your like terms. If there's any numbers you can add together, go ahead and do that first. And then isolate the variable. To get P by itself, what would you do on both sides? This is kind of tricky when we're starting with the number, but think what's in front of it. What kind of 117 do we have? We have a positive, so we're going to subtract. And P equals 63 then, or this angle is 63 degrees. Always, always, always show your equation work. I know that you can do it without it, but the equation is what we want to see. You are in pre-algebra, we want to see that work. We can also classify triangles, and we can classify triangles two ways. We can classify them by their angles and by their sides. Let's start with just the angles. An acute triangle will have 3 acute angles. You could draw a picture of this if you wanted. It would be 3 acute angles, which means all the angles have less than 90-degree measures. An example might be 30, 60, whoops, maybe I make that a little bit better. An example might be 30, 70, and 80. All of those have less than 90 degrees, so they're all acute angles. An obtuse triangle is a triangle with 1 obtuse angle. So it only has to have 1 obtuse angle. In fact, a triangle could never have more than 1 obtuse angle, because if you think about it, thanks to the triangle sum theorem, we know we can only have 1 angle over 90 degrees. Otherwise, when you add up your 3 angle measures, you would be over 180, and that can't happen. All of the angles must add up to 180. So maybe your obtuse angle is 100 degrees, it's more than 90, and then you have 30 and 50. So the other 2 angles are going to end up always being acute, an obtuse angle. If it has 1 obtuse angle, though, you still call it an obtuse triangle. And the last type is a right triangle. It's going to be a triangle with 1 right angle. So 1 angle will be right. The other 2 angles will be what type of angles? Let's think about this. If all together they add up to 180, and this one's 90, that leaves only 90 left for these 2. So they must both be acute. Maybe this is 89 and maybe this is 1 degree. They're still both acute angles. So fill in those blanks. You can draw the little sample pictures. Know that acute has to be all 3 angles acute. Obtuse and right will have acute angles, but they will have 1 obtuse angle if it's an obtuse triangle, and they will have 1 right angle if it's a right triangle. You can also classify triangles by the sides, and the 3 words you have in your paper are equilateral, isosceles, and scalene. You may have seen these words before. Equilateral is a triangle with 3 congruent sides, and that also means it's going to have 3 congruent angles. So an equilateral triangle will have 3 congruent sides. You can mark the congruent symbols with the little tick marks. Isosceles triangle then will have 2 congruent sides and 2 congruent angles. So maybe I have these 2 congruent sides, and actually these angles right in here will also be congruent, and one side that's not, maybe. And the last one is scalene. The scalene is a triangle with no congruent sides and no congruent angles. So all 3 would be different here. So you have 3 different lengths. I'm using the tick marks to show that the lengths are, in fact, for sure different. So in the next example, then, we're going to find the measure of each missing angle and classify each triangle by its angles and its sides. So I want you to solve, set up your equation, and then classify by both. Make sure you answer all parts of this question. So for the first one, our equation, again, we have a triangle, we have the angle, measures, expressions. We know all 3 of these angles are going to add up to be 180 degrees. So let's write our equation. Go ahead and solve your equation. All of these are x terms, so you can combine all of these like terms. 5x plus 3x is going to be 8x. 8x plus 2x is going to be 10x. 10x equals 180 degrees. You can solve that by isolating x. And you have x is equal to 18. Now we're not done. Make sure you read the directions. It says find the measure of each missing angle. So I found x. I still need to find the measure. So 5x, 3x, and 2x, I need to find those measures. 5x is going to be 5 times 18. 3x, 3 times 18. And 2x is 2 times 18. So do that math. Find the actual angle measures. You're going to end up with 3 answers here. These are your solutions to this. So 5 times 18 is 5 times 8 is 40, carry the 4. 5 times 1 plus the 4 is 90. 3 times 18, try that one. And 2 times 18, try that one. So here's our angle measures. Now we need to classify this triangle. Take a look at your angle measures. By the angle classification, this would be a right triangle. It has one right angle, must be a right triangle. By the side classification, look at the sides. Well, we don't know much about the sides in the picture, but we do know about the angles. All three angles are different, which means all three sides are different, which means it's scalene. Try the second one. Pause and try it on your own, and then press play to go over it. So on the second one, your equation should be b plus b plus b equals 180 degrees. You see that as 3b equals 180 degrees. And when you solve this, you should have found that b was 60. B is the only thing in each angle, so there's your angle answer. When you classify it, if all three are 60, then it is an acute triangle. And since all three have the same measure, it is equilateral. The last example then in this notes is going to be the same idea. We're still using this triangle sum theorem, but you're going to have a word problem and you need to set up your triangle. So let's try this together. The second angle in a triangle is 6 times as large as the first. The third angle is half as large as the second. Oh, that's a lot of words. So I'm going to just kind of pull out the highlights there. My second angle is, we know is equals, and it's 6 times as large as the first. So it's 6 times the first angle. And the third angle is equals half, I know half, as large as the second. As large is going to be multiplying again, and it's the second angle this time. So we kind of have two word equations. I think it helps to draw a picture. We have a triangle. We don't really know what kind of triangle it is, so just draw a general triangle. Let's see if we can fill in some algebraic expressions for these angles. All right, well, I'm talking about first, second, and third, so I'm going to label each angle like that. The second angle, that would be this one right here, is 6 times as large as the first. So I want to say this is 6 times that. I need something to represent this. Let's say x. The second angle then is 6 times the first, so the second angle would be 6x. And the third angle, this one down here, is half as large as the second. Well, if my second is 6x, then my third is going to be half of that. What's half of 6x? 3x. Now you have the algebraic expressions for your triangle. Write your equation and solve it. We know all three of these angles add up to 180 degrees. The hard part on this problem was coming up with those expressions. But once you have them, you're doing them just like the other ones. All three of these are x terms, so combine your like terms. 1x plus 6x plus 3x. This should look familiar. So x is 18. Am I done? Is that all I needed to find? Not quite. You need to find the angle measure, so you're going to have to plug it back in now. 18 is the first angle. The second angle's measure was 6 times the 18, and that's going to be 108 degrees. And the third angle was 3 times the 18 degrees, and that's going to be 54 degrees. Okay, the last one on your notes. These two right here, these are optional extra challenges. Try them after the quick check if you have extra time. Also, the page after this in your notes is an additional optional extra challenge. I'm just trying to keep you working and keep you challenged in this enrichment activity. So do these if you have time or if you're interested. Move on to your quick check.